This is Flow Rates Lecture Video 1, and I'm starting on page 471. And so, flow rates, let's just begin first by talking about what is a flow rate. Well, if you guys have ever been to a local hospital to visit someone and you see those IV bags hanging from an IV pole, well, what you guys need to know is that there are going to be times when patients are going to need to receive some form of medication, liquid form per se, directly into their veins. And so that is considered an intravenous medication. You hear us say IV medication, where that liquid medication goes directly into the patient's vein, which means that the medication itself must be sterile and it must be free of contaminants or microorganisms. So that means that the technician within the IV room is going to make these meds directly for the patient. And a lot of these medications, they can come as large as 1,000 milliliters. And an example of that is what we call a continuous infusion. And a continuous infusion is basically an IV bag for a patient that may have lost fluids and they need a replacement, maybe of sterile water or normal saline or lacetated ringers. All right. So anytime you hear, if you guys like those shows, like those ER shows, and they say, I need a 1 liter sterile water stat, because they're rushing someone into the emergency room, that means they've lost a lot of fluid. So they need a continuous infusion of sterile water that happens to be 1 liter, which is 1,000 milliliters. All right. Intravenous medications can also come as small as 50 milliliters. And those can be what we call IV PB, and that stands for intravenous piggyback. Medications that you'll see in the intravenous piggyback is like an antibiotic, antifungal medication, those type of medications. I mean, you can still, quote unquote, turn it into a liquid medication and put it directly into a patient's vein. But those are the type of medications that you'll see. As you guys read on page 471, you guys also, it talks about the different therapies. They have a maintenance therapy where, again, if you're losing fluids, you need to regain fluids, or you need electrolytes or glucose. That's going to be a maintenance therapy. So a doctor can order a maintenance therapy IV bag. All right. A doctor can also order a replacement therapy. Of an IV, where replacement therapy is you're low on your electrolytes, so you need to go ahead and rebuild that within your system and meet your calories for the day. All right. You also can see a restorative therapy where you guys, basically your vital signs, you need to restore those vital signs. All right. And so that could be a number of different fluids. One of the things that I want you guys to know is that when we talk about flow rates, you may also hear the term infusion rate or administration rate. All right. they all mean the same thing. It's the rate of medication the patient is receiving if I can spell today, you guys. It's the rate of medication a patient is receiving over a period of time. All right. So you guys are going to learn how to calculate flow rates. And we can manipulate these formulas as we go on, but you guys are going to learn that within this chapter. So there are some flow rate formulas that I want you guys to remember. All right. And these formulas are actually listed on your, you guys, of course, you guys know that like all of your formulas on your conversion sheet that was given to you at the very beginning of the semester. But your flow rates, if you guys can just remember these formulas, it'll kind of help you out from this point on. So whenever you are looking, if the problem is asking you to determine milliliters per hour, you're just going to take the total amount of milliliters over the total hours. This is considered a flow rate. Okay. This is number one. Number two, another flow rate they may ask you to find is milliliter per minute, where basically you take the total amount of milliliters the patient is receiving over the total amount of minutes. Again, what is a flow rate? Flow rate is basically the rate of medication the patient is receiving over a period of time. The time for milliliters per hour happens to be in hours. The time milliliters per minute happens to be in what? Minutes. Another formula that I want you guys to know is a flow rate can also be determined where it says the rate of medication the patient is receiving over a period of time. Well, the rate of medication could be in its liquid form or it could be in its weight form. So if the doctor or if the problem is asking, you know, the weight of drug per time, well, that could be a number of things. That could be milligrams per hour. Well, you take the total amount of milligrams a patient is receiving over what? The total hours. That could be grams per minute. It just all depends on what the problem is giving you. The total amount of grams over the total amount of minutes. I'm not going to write down every formula that you're going to come across, but if you can remember, I'm going to write this neater. If you can remember the weight of drug over the total time, then you'll be able to solve that problem. All right. The weight of drug could be in milligrams, micrograms, grams, kilograms. The time could be in hours or minutes. Whatever the problem is given and whatever it's asking, if it's asking what's the total amount of milligrams per hour and the problem is in kilograms, you have to change it to milligrams. And if the problem is in hours, you just divide it over the amount of hours. All right. There's going to be times where they want to know the duration, which means how long an IV will last. So that means they want time. So I'm going to put in parentheses time here. Well, that can be solved by taking the total amount of milliliters the patient is receiving over the flow rate of milliliter per hour. So you think about it, the milliliters cross out, leaving you with hours. That's the whole purpose of these formulas, is to set your formula up to where all your like units cross out, leaving you with what it is that you're looking for. If the duration of time wanted in minutes, then you would take the total amount of milliliters over the flow rate of milliliter per minute, because your milliliters cross out, leaving you with minutes. Another formula that I want you guys to know, I'm going to have to erase this. All of these formulas again are on your conversion sheet. But another formula that I want you guys to know is the drip rate. All right. Drip rate is going to have the units of drops per minute. And that formula is, you're going to take the total amount of milliliters the patient is receiving over minutes and multiply it by your drop factor. Your drop factor could be given. All right. Your drop factor could be given. Your drop factor has the units of drops per milliliter. All right. But keep in mind that if not given, you are to use 60 drops per 1 milliliter. All right. If not given, you are to use 60 drops per 1 milliliter. All right, so let's try a couple of these problems. So let's start with practice problems. Let's start with practice problems B on page 486. All right, let's start with practice problems B on page 486. So number 1, it says a physician orders. So the first step I'm going to do is pull out the information. So whatever the physician orders is my prescription. So it says that they order 2 liters of lacetated Ringer's solution over 12 hours. It tells me that my drop factor is 20 drops per milliliter. The first question, or the question wants to know, is how many drops per minute will be infused. So they want me to find my drip rate. Your drip rate is drops per minute. In order to solve that, you have to take the total amount of milliliters the patient is receiving. So in this case, they're receiving 2 liters. Well, that's 2,000 milliliters over the total amount of minutes. Well, the time is in hours, correct? So you need to change 12 hours to minutes by multiplying by 60. If you take 12 hours and multiply it by 60 minutes, that's over 1 hour. Hours cross out, that leaves you 720 minutes. So there's 720 minutes in 12 hours. And then you multiply that by your drop factor of 20 drops per 1 milliliter. Remember, you set your